Okay, so we're going to go through what we did yesterday in the live video on collecting like terms in algebra. So like terms are terms in algebra that have the same letter. So if we have a look at the first example here, we've two pipes of length 5a and 3a are joined together. So if we just take one of these little green cylinders, we're just going to call that 1a. So you can see here that we've got 5 of them. So we're calling that 5a. And over here, we've got 3 little cylinders, so we've got 3a altogether. If we added those together, very simply, we're going to get 8a. Okay, they're the exact same pipes, so they just can be joined together because they are like terms. So 5a and 3a are like terms. They can be combined or collected together. Okay, so it's the same thing for these examples here. So if we have a look, and the first one, they're all the same. They're like terms. We're calling each individual one an x. So in the first one, we've got 6x altogether, and we're adding that to 4x. So when we add 6x and 4x together, we're going to get 10x. In the next one, we've got, these are the y's. Each one is individually a y. So we've got 5y's and 2y's. So altogether, we've got 7y. The last one then, we're calling them z's. Each individual green cylinder is a z. We've got 4 z's, then we've got 2 z's, and then we've got 1 z. And when we add them all together, we end up getting 7z. Okay, so very simply, when the term is the same, so these are the same, they're like terms, we can just add them together as we'd add the number 6 and 4. Okay, and the same for these two here. In the previous one, on its own, it's just x, or on its own here, it's just called z. Okay, so going on to the first example, you've got a few more to do yourselves, but we can see that in this one, very simply, they're all the same terms. So we can just collect the like terms. So for 2a, they're all the same. We've got 2n plus 3n plus 1n. Okay, the 1 isn't written there, but it's just an n on its own, like one of the. All right, so 2n plus 3n plus 1n is going to give us 6n. The next one, 4p plus 2p is 6p, minus 1p is 5p, and then 8q minus 2q is 6q, and 6q minus 3q is 3q. So it's just straightforward adding and subtracting. Now, what happens if we're adding terms that aren't alike? So let's take this necklace, for example. It's made from 2 kinds of beads, one of length A and one of length B. So each individual blue circle, we're going to say is a 1A. So I've got 4 A's over here, 4A, and I've got 4A over here. And one of these hexagon shapes is a B. So I've got 3 B's altogether. And the total length of the necklace will be the same as saying 4A plus 4A plus 3B. So adding them all together. 4A plus 3B plus 4A. Now, we already know we can only collect the like terms. So the 3B has to stay there. Okay, it can't be added to anything. But we can add the like terms together. So we end up getting 8A plus 3B. Okay, so the last bullet point, very important. 8A and 3B are unlike. Okay, so because they're unlike, they cannot be combined. Okay, so then we just simplify this expression. So when we're collecting the like terms, use a different colour pen and circle all the like terms together. So we'll start with the x's. We're going to circle the x's. And when we circle them, we have to circle the sign before the number. So I'm bringing the plus 2x and the minus 3x. So I'm going to add them together. 5x plus 2x is 7x, and 7x minus 3x is 4x. Okay, and now I'm going to collect the y's together. Plus 4y plus 1y is going to be plus 5y. Okay, I can't go any further, can't collect any more like terms. That's the answer. I've simplified it. They're not asking us to solve for x, just to simplify the expression. Okay, necklaces are made from 2 beads of length x and y. we want to write the total length as simply as we can. So here we've got 3 unknowns, 3x, and the same over here. So 3x, 3x, and 2y. Okay, I know in the previous one we said they were a's and b's. It doesn't matter. They're just unknown values. So we want to simplify this. Okay, do we see? Can we collect anything there together? So we can get the 3x and the 3x. Together that's going to give us 6x. We can't collect the 2y with anything, so it just stays as 2y. In the next one, we've got 2x, 2x, 3y, and 3y. So we're going to collect the x's. We end up getting 4x, and then we're going to collect the y's. And we end up with 6y. Can't do anything more. That's our final answer. Okay, terms which use different powers are not like terms. So for example, if I had 2z plus 2z squared, I can't collect them together because z and z squared are completely different values. So I can't add the 2's together there. Okay, another example, if I had 3x plus 5x squared, no, can't do anything there. X and x squared, they're unlike terms. That may as well be a y or a z. I can't add them together. Okay, so I cannot simplify those. They just stay as they are. So let's see what we can simplify here. We're going to collect the like terms. So we'll get the x squareds first. Okay, so we'll write them out. We have 3x squared minus x squared plus x squared plus 5x squared. When we simplify that, we end up getting 8x squared. Okay, so 3x squared minus 1x squared is 2x squared. 2x squared plus 1x squared is 3x squared. 3x squared plus 5x squared is 8x squared. Okay, and then we're going to collect the x's. These are the only like terms there, and we get plus 6x. Can't go any further with that. Can't collect them any further because x and x squared are unlike terms. Okay, so let's simplify this expression here. So we're going to collect the x's, and that's going to give us 5x. And then we're going to collect the y's. 6y minus 4y is going to be plus 2y. Second one, collect the x's. 5x minus 3x is 2x. And then we're going to collect the y's. Plus 2y, plus 6y, plus 8y. And the last one, 4x minus 2x is 2x. And plus 2y plus 3y is plus 5y. Okay, there's more for you to do on the PowerPoint. So go back to the PowerPoint and see, can you do the others? And then last one is when we've got a square. So there's still unlike terms here. So we can collect the x's. That's going to give us 6x. Then the x squareds is going to give us plus 8x squared. Can't simplify it any further because they're not like terms. Next one, collect the y's together. We get 9y. Then we're going to collect the y squareds. 6y squared minus 3y squared is plus 3y squared. Last one, collect the z's. That should be a plus z squared there. We get 7z and z squareds. Add them together, we get 4z squared. Can't simplify them any further because z and z squared are completely different values. Okay? Okay, so I want you to go back to the PowerPoint and try the rest of the questions that were put up there. I've done the first 3 in each set for you, and that's due for tomorrow. Okay?